Hey everyone, and welcome to The Explainer, where we take big, complicated ideas and break them down into something simple and clear. So let's start with a big question. Think about a time you were faced with a problem that just felt impossible. Sorting a massive pile of documents or planning a huge project. The sheer size of it can just be completely overwhelming, right? Where do you even begin?
Well, believe it or not, there's a really elegant strategy for this. And in computer science, we call it divide and conquer. The name pretty much says it all. You take that giant, scary problem, you break it down into smaller, bite-sized pieces, you solve each of those little pieces, and then you just cleverly put the solutions back together.
Now, in this explainer, we're really going to focus on the idea behind one of the most famous algorithms that uses this exact strategy. We're talking about the what and the why. So, if you're looking for a super detailed, line-by-line code walkthrough with a full dry run, don't worry, we've got you covered. Just check out the resources in the description below.
Okay, so here's our game plan for today. We're going to start with that core strategy itself. Then we'll meet our main event, merge sort. After that, we'll pop the hood and see exactly how it works, figure out why it's so darn good at what it does, and finally, we'll zoom out and see how this way of thinking is useful for way more than just sorting numbers.
All right, let's kick things off with this core technique, because honestly, it's more than just a little trick. It's a whole philosophy for solving problems.
At its heart, it's really this simple three-step dance. You divide the problem up, you conquer the smaller pieces, and then you combine the results. Now, that word recursively in the middle there, that's just a fancy way of saying you keep applying that same divide logic over and over and over again until the pieces are so tiny they're basically already solved.
And this is not just some niche idea. It is the powerhouse engine behind some of the most critical algorithms in all of computer science. We're talking about things like merge sort and quick sort for arranging data, and even binary search for finding things incredibly fast.
So let's bring this back to our star player for today. Let's see how this big idea gets turned into a real practical sorting method that developers have been relying on for years. And this right here is merge sort in a nutshell. It is the perfect, almost textbook example of divide and conquer in action. Its entire strategy, its whole identity, is built around this beautiful idea of splitting things apart and then putting them back together in a much more orderly fashion.
So, how does this thing actually tick? Let's get our hands dirty and really look at the mechanics. It all comes down to two key phases, or two key functions, working together.
Okay, so the whole show is run by this main function we'll call merge sort, and its job is super simple. All it does is divide. It just asks one question: is this list bigger than one item? If the answer is yes, it finds the middle, splits the list in two, and then here comes that recursive magic again. It calls itself on the first half and then calls itself again on the second half. It just keeps doing this, splitting and splitting until it can't split anymore.
So let's walk through it. Imagine we start with this jumbled up list of 8 numbers. The very first thing merge sort does, bam, it slices it right down the middle.
But it doesn't stop there. Because it's recursive, it immediately does the exact same thing to those 2 new lists, splitting them in half again.
And this process just keeps on going until we literally can't divide anymore. We're left with a bunch of these tiny single-item lists. And here is the aha moment. A list with just one item in it is by definition already sorted. The divide part is done. We've conquered the problem by just breaking it down this far.
Okay, so we've successfully broken our big, messy problem into a bunch of perfectly sorted little pieces. But now for the real magic. How do we put them all back together in the right order? Well, this is where the second key function, the merge function, steps onto the stage to do all the smart work.
So let's jump ahead a little bit in the process. Imagine we've already done some merging, and now our job is to merge these 2 smaller, already sorted lists. One has a 1 and a 5, and the other has a 3 and an 8.
The merge function is so cool because it's so systematic. It looks at the first number in each list, in our case, 1 and 3. It asks which one's smaller. Well, 1 is. So it grabs the 1 and puts it into our new combined list. Then it moves its attention to the next number in that left list, which is 5. It compares again. 5 versus 3. 3 is smaller, so it scoops up the 3 and puts it next. It just keeps doing this simple, elegant dance. Compare, place, move on, until it's built one single, perfectly sorted array from the 2 smaller ones.
So, all that work, all the splitting, all the careful merging, you might be wondering, is it worth it? And the answer is a resounding yes. It has a massive payoff in performance and reliability.
What's absolutely incredible here is the consistency.
Just look at this table. Now, that O(n) log n might look a little scary, but all it really means is that the algorithm is super efficient and, more importantly, predictable. As your list gets bigger, the time it takes to sort grows in a very controlled way. Unlike some other algorithms, merge sort has no kryptonite. There's no worst-case arrangement of data that will suddenly make it grind to a halt. Whether the list is a total mess or almost sorted, it performs beautifully every single time, and that predictability is gold.
Now, there is one trade-off for all this amazing consistency, and that's memory. To do all that clever merging, it has to create temporary little lists to hold the pieces. Basically, it needs extra memory that's about the same size as the original list you're sorting. In nerd speak, we call that O of n space complexity. It's the one price you pay for that rock-solid performance.
So what's the bottom line? Why do people love merge sort? It really comes down to two things. First, that predictable, no surprises performance. And second, it's what we call a stable sort. That just means if you have two identical items in your list, it guarantees they'll stay in their original order. That might not seem like a big deal for numbers, but if you're sorting customer data, it's absolutely crucial.
Okay, for our last section, let's just zoom all the way back out. We've been deep in the weeds of sorting numbers, but the core idea here is so much bigger than that.
And this right here, this really says it all. Merge sort isn't just a clever piece of code, it's a problem-solving philosophy brought to life. This simple idea, divide, conquer, combine, is a blueprint for tackling complexity in just about any part of your life. So, the final thought I want to leave you with is this. Where can you use this? That overwhelming project at work, that new skill you want to learn, even something as simple as organizing a messy room. What impossible task could you start making progress on today? Not by trying to do it all at once, but just by asking, how can I split this in half?